Hello students, in today's lecture I will discuss about DDA algorithm. DDA algorithm is a line drawing algorithm, and basically these algorithms are designed for raster scan systems. Uh, in raster scan systems we can see that it is the most common type of graphics monitor employing a CRT, uh, and basically it is based on television technology. And in raster scan systems, the electron beam is swept across the screen one row at a time from top to bottom. The beam intensity is turned on and off to create a pattern of illuminated spots. Picture definitions is stored in a memory area called the frame buffer. So this is the diagram of raster scan system, and we can see that in this the electron beam is moving across the row from left to right. And basically when the electron beam moves across a row, its intensity is turned on and off, and basically it depends on the picture definition where to draw the picture. And the definition of the picture is stored in a memory area, and the memory area is called as a frame buffer. So what is happening? We are implementing the DD algorithm on raster scan systems, and these algorithm can be used to draw a line. So whenever you are using a raster scan system, there is a problem of scan conversion. The problem is that whenever you are drawing any line on the system, the line does not appear straight, except in few cases. For example, if you are drawing a line which is completely horizontal, if you are drawing any line which is completely vertical, and if you are drawing any line which is at an angle of 45 degree, in these three cases the line is straight, but in other cases the line does not appear straight, and this is called as the problem of scan conversion. So whenever you are drawing such line, there is a kind of aliasing in the line, and this aliasing is also called as jaggies. So what we have to do, we have to minimize aliasing, or we have to minimize jaggies in the line. So here is a diagram. So you can see that we are having one initial point and we are having one final point, and whenever you are drawing a line which intersect the initial and the final point, you can see that the line is crossing various pixels. And here the question arises, which pixel we have to activate. If you are activating these two pixels simultaneously, and if you are activating these two pixels simultaneously, and whenever you are drawing any line which crosses all these pixels, then obviously the line does not looks a straight line. So what is happening? We have to choose all those pixels which are very much nearer along the true line path. In that case, we could avoid aliasing, or we could avoid jaggies in those lines. So we have to consider these things in our mind. So considerations to keep in mind is basically the line has to look good. That means whenever you are drawing a line, the line should appear straight. For that you should avoid jaggies or aliasing, and it has to be lightning fast. That means it can be drawn fast on the raster scan systems. So before moving to DD algorithm, here is a simple mathematics to draw a line, and we know that in Cartesian coordinate system whenever you are dealing with the line equations, the equation of line can be, it is y is equals to mx plus b, and we know that in this equation of line, m is the slope of the line and b is the intercept. Okay, and we know that if you want to calculate the slope of the line, that is y and minus y0 upon x and minus x0, and the intercept of the line can be given as b is equals to, so in this diagram we can see that there is a line which is having initial point x0 y0 and the final point x and y end, and from these 2 points we could easily calculate the slope, that is the m, and the intercept, that is the b, of any line. So here is a diagram which is representing various lines, and what can be the slope corresponding to each line, it has already been given in this figure. The slope of a line m is defined by its start and end coordinates. The diagram below shows some examples of line and their slopes. So here we can see that any line which is parallel to x-axis, the slope of the line is 0, and any line which is perpendicular on x-axis, the slope is infinite. And we know that any line which is having any inclination of 45 degree, in that case the slope of the line is 1. So here is an example. In this we are having a line whose initial point is 2 comma 2 and the final point is 7 comma 5, and what we are doing before proceeding to DD algorithm, what we are doing, we are applying the concept of simple mathematics, and by that concept we are going to plot a line whose initial point is 2 comma 2 and the final point is 7 comma 5. So this is a simple calculation, and from the given line we can easily find the slope of the line, and it is y2 minus y1 upon x2 minus x1, which is coming around 3 upon 5, and similarly we can calculate the intercept of the line, which is coming 4 upon 5. So now what we are doing, we are starting from the x values. We know that x is equals to 2, we are already having a point, that is y is equals to 2, and for the value of x is equals to 5, we are already having the value of y, which is 7. So what we are doing, we are incrementing the value of x. So we know that initial value is 2, so the next incremented value of x is 3, and what is happening, we are calculating the value of y at x is equals to 3, and from the simple equation of line we can simply, what we are doing, we are simply substituting the value of x, which is 3, and the slope, which is 3 upon 5, and the intercept, which is 4 upon 5, and we are getting it is 2 3 upon 5. And similarly what we are doing for x is equals to 4, for x is equals to 5, and for x is equals to 6, what could be the value of y, we are calculating the value of y across all those values of x. So you can see that at y x is equals to 3, the value of y is coming around 3, and at x is equals to 4, the value of y is coming around 3, and for x is equals to 5, the value of y is 4, and for x is equals to 6, the value of y is 4. And what we are doing, we are rounding the values. Now just round off the result and turn on these pixels to draw our line. So you can see from the figure that if you are following this simple concept, you can see that the line which you are drawing, it cannot be a straight line, because whenever you are connecting these two pixels and whenever you are connecting these two pixels, then definitely the line could not appear straight, and certainly such line could have aliasing. So the concept that just we have seen is a kind of directly using line equation. What we are doing, we are directly using the line equation, and we are trying to we are trying to draw the line. And what are the problems that we are facing? Whenever you are using this concept, you are doing you are doing multiplication, and we know that whenever you are performing multiplication or division in computers, and obviously these calculations are very complex. And second thing, what you are doing, you are rounding the values, and again rounding of the values is a time consuming process which requires some additional calculations, and because of these rounding of values, the line is not appearing straight, and there is a aliasing in the line. So we cannot use this concept because it has some drawbacks. So we need some kind of faster solution, we need some kind of good solution. For that we are moving to the DD algorithm. So this is the algorithm. It is called as digital differential analyzer algorithm. So DD stands for digital differential analyzer, and basically it is a kind of scan conversion line drawing algorithm based on calculating either delta y or delta x. So what is delta y? Delta y is nothing, it is y2 minus y1, and delta x is it is x2 minus x1. And the name of the algorithm is based on some machine, and you can see in the diagram this is the machine, and the name of DD is based on this machine, and this machine is used to solve ordinary differential equations. Okay, so we can say that the algorithm is a kind of, it takes an incremental approach in order to speed up scan conversion. Simply calculate yk plus 1 based on yk. So what we are doing, we are incrementing either the value of y or we are incrementing the value of x. If I am incrementing the value of x, then I am approximating the value of y, and if I am incrementing the value of y, in that case I am approximating the value of x. So here is the simple concept. You can see when the slope of a line is between -1 and 1, beginning at the first point in the line, and by incrementing the x coordinate by 1, calculate the corresponding y coordinate as follows. So what we are doing, initially we will start from calculating the slope of a line, and if the slope of a line is -1 and 1, so in that case what we are doing, we are simply incrementing the value of x. And what about the y values? We are approximating the y values. So what can be the formula for approximation? The formula is very simple. It is yk plus 1 is equals to yk plus m. In the other case, what is happening, if the slope is not between -1 and 1, in this case what we are doing, we are incrementing the value of y and we are approximating the value of x, and the approximation can be given as xk plus 1 is equals to xk plus 1 upon m. So these are the two figures. In this case you can see that here what we are doing, we are simply, in the first figure what we are doing, we are simply incrementing the value of x. That means if the initial value is xk, so the next value is xk plus 1. And what about y? We are approximating the value of y, and the approximation formula is very simple. You have to add the slope of the line in the y values. While in the other case what we are doing, in this case the line is having the slope more than 1. In this what we are doing, we are incrementing the value of y and we are approximating the value of x by adding the inverse of the slope. Okay, again the values calculated by the equations used by the DD algorithm must be rounded to match pixel values, and whatever the values it is coming after approximation, we have to round those values. So again, in the DD algorithm, we are also using the concept of rounding. So here you can see the steps of the algorithm. These are the steps which we have to follow to implement this algorithm. So you can just go through this step. This is the pseudocode of the algorithm. If you want to implement this algorithm on through C, C++ or Java, for that here is a pseudocode is available, and by this pseudocode you can easily implement the algorithm. So here is a numerical of DD algorithm, and the question is calculate the points between the starting point 5,6 and ending point 8,12. So we have to draw a line whose initial point is 5,6 and final point is 8,12. So 5,6 is the initial point and 8,12 is the final point. And we know that in DD algorithm we are calculating delta x and delta y, and we know that delta x is xn minus x0 and delta y is yn minus y0. So you can simply calculate the value of delta x and delta y. After that we have to calculate the slope of the line, which is m, and it is coming around 2, and we know that the slope is more than 1, and whenever the slope is more than 1 we are simply incrementing the value of y and we are approximating the value of x. So you can see this as m is greater than 1, x will be approximated and y will be incremented. So you can see this. So we will start from the initial point 5, 6, and what we are doing, so we are starting from the first value, that is 5,6, and in this we know that the slope is more than 1. So what I am doing, I am simply incrementing the value of y. So I am starting from 6, next incremented value is 7, then 8, 9, 10, 11, and finally I am getting the value 12, and this is my final point. So what about the x values? So we are simply adding the inverse of the slope, and I know that the slope of the line is 2, so the inverse value is 0.5. So what I am doing, I am simply adding the value 0.5 in each value of x. So starting from 5 I will get 5.5, then again I am adding 0.5, 6, again adding 0.5, 6.5, 7, 7.5, and finally I am getting 8. And in the next step what I am doing, I am rounding all these values. So 5.5 becomes 6, 6.5 becomes 7, 7.5 becomes 8, and finally what I am doing, I am plotting all those values starting from 5.5,6, the next value is 6,7, then 6,8, 7,9, 7,10, 8,11, 8,12. And here in this figure I can see that the line is not straight. Why it is not straight? Because simply you can see that corresponding to a single value of x, that means for x is equals to 6 you are plotting y is equals to 7, as well as you are plotting y is equals to 8, and because of this the line is not coming straight and there is a kind of jaggies or aliasing in the line. So this is the main drawback of DD algorithm. Again we are having the aliasing in the line, but you can see that the most advantage of this algorithm is that we are not using any kind of multiplication, we are just doing addition. So the DD algorithm is much faster than our previous attempt. In particular, there is no longer any multiplication involved. However, there are still two big issues. First is accumulation of rounding off errors can make the line drift away from what was intended. And second is the rounding operations and floating point arithmetic involved are time consuming. So these are the limitations you can see of DD algorithm, and these limitations are overcome by the next algorithm, and the next algorithm is the Brasenham's line drawing algorithm that we will discuss in the next lecture. Thank you.